Okay, today we're going to work a little on choosing the right method, the best method for each problem. And it's a review. Okay, so the directions say to choose the method you feel is the easiest, graphing, substitution, or elimination. Place the letter in the box, G, S, or E for each problem to identify the method you'll be using before you solve the problem. You can use the graph if you want. Um, so I'm looking at this one and I see I have X isolated. If I don't see y equals mx plus b, I'm not graphing. So for this, I'm going to substitute. I'm going to take what x is equal, and I'm going to plug it in for x. So I have 2, and instead of the x, I'm putting in 4y plus 1 minus 3y equals 12. Take your time, keep your signs straight. So 2 times 4y is 8y, 2 times 1 is 2. Bring down that negative 3y, don't forget about it. Now here I'm on one side, so I'm not going to use the inverse or the opposite. I'm just going to combine 8y and negative 3y, which will give me 5y plus 2 equals 12. So now I'm going to go back to the slide. I'm going to subtract 2 from each side. So I have 5y equals 12 minus 2 is 10. I'm going to divide each side by 5. So y is 2. Now I'm going to put that in. You have to be careful here. Unlike elimination, I use the top one. So now I have to put this into the bottom one. So now I have x equals 4. Instead of the y, the 2 goes in, so the y is gone, plus 1. So I have x equals 4 times 2 is 8, plus 1, x is 9. So my answer is 9, 2. If I were to graph, they would cross at the point 9, 2. All right. So I guess this one could go either way here. So we just did substitution. So let's make this one into elimination. Okay. I'm going to force this into elimination by multiplying the top numbers by negative 3. So I can cancel out those 3 x's. So the top one will become negative 3x minus 3y equals negative 9. And the bottom will leave the same. So I'm going to get rid of the 3x's by 3x's, and I'm going to add negative 3y and negative 4y, which will give me negative 7y, and this will be negative 28. When I divide by negative 7, I have y equals negative 4. And again, I can plug this into either one. I'm going to go right here where it's easier. So I have x minus 4 equals 3. I'm going to add that 4 to x equals 7. So my answer is 7, negative 4. All right, number 3. Okay, so I know we're not a fan of graphing, but look, these are both in slope-intercept form, so I'm going to graph them. And you're going to have to graph on your test. So the first one is y equals x minus 6. So I'm going to start at negative 6. My slope is 1, so up 1 over 1. Again, I know we are far off from this, but you need to use your straight edge so you can see where they actually cross. And then the other one, you start at 2. Oh, look at this. They have the same slope. Many of you might have caught this before you went ahead and graphed. But if it says solve by graphing, I still need to see that these are parallel lines, and your answer is no solution. Okay. Oh, what should we do here? Well, I see we have the same coefficients if we move these around, so let's eliminate. So I'm going to flip this around to be negative 2x plus y. I didn't change anything except flip the two variables around so the x's and y's lined up, if I can write. So my 2x's already cancel. So now I have 1, 2y's equals 6, and I divide by 2, so y is 3. I'm going to plug it right into the top. So I have 3 minus 2x equals 1 because I plugged that in for the y. I'm going to subtract the 3 from both sides. So I have negative 2x equals negative 2. Not going to let me write. Oh, let's see where I was. I was right here. So I have negative 2x equals negative 2. I'm going to divide by negative 2 on each side, so x is 1. So my answer is 1, 3. Yeah, that definitely was the best way. Super quick. All right. Oh, look here. Slope-intercept form again. So I'm going to go back to graphing. So I have y equals 4x minus 3. I'm going to start at 3. And my slope is 4, so up 4 over 1. Do the best I can when I don't get a straight edge like you guys. Okay, and this is y equals x plus 6 right here. Look at that. It's not going to cross on the graph. Just off. So we're going to have to change this to substitution. I'm going to plug this in right there. So I have 4x minus 3 equals x plus 6. I know when you're plugging the whole thing in like that, it sometimes confuses you. Now you have variables on both sides. So I'm going to subtract x on each side. So I have 3x minus 3 equals 6. Add 3. So now I have 3x equals 9. Divide by 3, x equals 3. Again, we can go either one. Going to go to the top. No, I'm going to go to the bottom. We used the bottom. So I have to go to the top. So 4 equals 4, or y equals 4 times 3. Instead of the x, minus 3. Y equals 12 minus 3. So y is 9. So I have 3, 9. All right. I think we should eliminate here. We're going to have to do some multiplication. I'm going to multiply the top one by negative 2 so we can get rid of the x's. So I have negative 2x plus, because I have negative 2 times negative y, plus 2y equals 0. Let's line those up and see what's in store for us. So say goodbye to the two x's. I have 6y equals 18. Oh my goodness. There we go. Going to divide by 6. So y is 3. I'm going to plug that into the top one, but let's be super careful here. And this is a really good example. You're plugging into a negative, so you're going to plug that 3 into negative y. So this will be x minus 3 equals 0. We're going to add 3. So x is 3. So our answer is 3, 3. Number 7. I don't think I want to try to find a y-intercept of 1/3, even though y is by itself in the second one. You know what? If we multiply this by 3 to eliminate, we won't have any fractions left because 1/3 times 3 is 1. So let's do that. Let's rewrite the top one. We're trying to eliminate the x's. Oh, but I'm not so sure that's going to work. Let's rearrange it first. Let's erase all this. So this one has a lot going on. Let's leave the top one alone. And let's rearrange this one. So I have y equals 3x plus 1/3. I want to bring that x over to the other side, so I'm going to subtract 3x. So now I have y minus 3x equals 1/3, and everything will line up. Y minus 3x equals 1/3. So now we're going to multiply everything by -3. So these have opposite signs. So let me rewrite again. Top one stays the same. Now I have -3y plus 9x minus 1. And lo and behold, look at this. This is a y. Canceled, canceled, canceled. So 0 equals 0. So this is a lovely infinitely many solutions. Took a while to get there. Okay, number 8. So we could multiply the top by 7, or we can try to isolate the x. Let's multiply the top by 7. If we do that, we can eliminate those x's. So I have 7x plus 14y equals 42 at the top. Okay, let's see what happens here. Our numbers are bigger, so we're going to get rid of our 7x's. Here I have 17y and 42 minus 8 is 34. And if we divide by 17, y equals 2. So I'm going to plug that. We're eliminating, by the way. This is an e. I'm going to plug that in up here. So I have x plus 2, and instead of the y, times 2 equals 6. Do that multiplication first. Subtract 4. So we have 2 as an answer. Number 10. We're going to take another shot at graphing because they're both in slope-intercept form. We'll see if they intersect on the graph this time. So I'm going to start at 5, and then again, I have a slope of 1. So up 1, over 1. Let's fill up the coordinate plane so we can make sure we see where they intersect, and let's hope. This time I'm starting at -10, and I have a slope of +2. Yeah, this is going nowhere. Not happening. Well, nope. Not going to make it. So let's substitute. So I'm going to set this up, and then I'm going to stop the video, and I'll start on another part. So I'm going to take this and put it here. So x plus 5, instead of that left side y, equals 2x minus 10. All right, I'm going to stop here. I'll see you in the next part.